On August 5th, at 2:35 in the morning, a 5-ton piece of human wreckage slammed into the moon at 5,400 miles an hour. Nobody planned it. Nobody aimed it there. And on the other side of the planet, a telescope in the Chilean desert was already pointed at the exact spot, waiting to catch the chemical signature of the impact as it happened. The object was the upper stage of a SpaceX Falcon 9 rocket, launched back on January 15, 2025, carrying 2 robotic moon landers, Firefly Aerospace's Blue Ghost and ISpace's Resilience. Once its job delivering those landers was finished, the empty stage stayed exactly where rocket stages usually end up after a lunar mission, drifting quietly through space with nowhere in particular to go. Here's the part that makes this story stranger than a simple SpaceX crashed a rocket into the moon headline. Nobody steered it there. According to NASA officials, a mixture of solar radiation pressure and the moon's own gravity slowly bent its path over the following 7 months, nudging a piece of dead hardware onto a collision course nobody had originally planned for. SpaceX had actually performed a separate maneuver earlier, specifically intended to keep the stage safe and compliant with disposal regulations. Nature simply had other plans. An independent astronomer named Bill Gray was the one who first spotted where this was heading. Gray has made something of a specialty out of tracking exactly this kind of orbital debris, and he flagged the coming impact days in advance, giving observatories around the world enough lead time to actually prepare for it. The predicted impact site was near Einstein Crater, close to the moon's western edge as seen from Earth, arriving at around 6:35 UTC, or 2:35 a.m. Eastern Time. And this time, because everyone knew it was coming, astronomers didn't just watch. They got their instruments ready. This isn't actually the first time something like this has happened, and it isn't even the first time it happened publicly, with cameras and telescopes watching in advance. Back in 2022, a mysterious piece of rocket debris was tracked on a collision course with the moon, and for weeks, nobody could agree on exactly whose hardware it actually was. Some early tracking data pointed to SpaceX. Later analysis suggested it more likely belonged to a Chinese Long March rocket instead. That earlier event ended up drawing far more public attention than anyone expected, according to the same independent tracker, Bill Gray, who flagged this new impact well in advance, specifically because of how much interest that first mystery case had generated. This time, there was no mystery. The origin of the debris was known from the start, and so was almost everything else about it, right down to the minute of impact. The European Southern Observatory pointed its very large telescope in the Atacama Desert of Chile, directly at the predicted impact site. In the minutes after the collision, the telescope caught something remarkable. Spectral lines, essentially a chemical fingerprint written in light, revealing sodium and lithium gas, glowing in the debris plume for somewhere between 5 and 10 minutes after impact. According to ESO's team, the sodium most likely came from the lunar soil itself, kicked up and briefly vaporized by the violence of the impact. The lithium, on the other hand, almost certainly came from the rocket stage, rather than the moon. For a few brief minutes, scientists were reading the elemental ingredients of both the spacecraft and the lunar surface, mixed together in a glowing cloud, entirely by accident. The impact itself carved out a fresh scar on the lunar surface, with early estimates putting the new crater at somewhere around 60 feet wide. That's a modest crater by lunar standards, but a real, permanent mark, added to a surface that already carries billions of years of impact history. There was even a small chance that skywatchers on Earth could catch a glimpse of the aftermath without a research-grade telescope. Researcher William Joe at the University of Texas at Austin published a study days before the impact modeling exactly how high the resulting dust plume might rise above the lunar surface. According to that research, the impact site sat close to the boundary between lunar day and night, a detail that mattered because sunlight striking a rising dust cloud from a low angle can make it considerably easier to spot against the darker sky behind it. Catching sight of it required a fairly capable telescope, ideally one able to record high-speed video, along with clear skies and a good deal of luck. It wasn't a guarantee, but for a brief window, it turned an ordinary act of orbital housekeeping into something amateur astronomers across the Americas actually had a real, if slim, chance of witnessing for themselves. It's worth pausing on just how ordinary this kind of impact actually is in the bigger picture. According to a NASA official, a meteoroid carrying roughly the same amount of energy as this rocket stage hits the moon about once every 6 days. The moon has no atmosphere to burn up incoming debris the way Earth's does, so it has been quietly absorbing hits like this from natural sources for its entire 4.5 billion year existence. What made this particular impact different wasn't the physics of the collision. It was that, for once, humans knew exactly what was about to happen and where, and had telescopes ready and waiting instead of finding a fresh crater by accident months later. That distinction matters because it points toward a much bigger, messier problem quietly building up around the moon. This Falcon 9 stage isn't an isolated case. According to recent estimates, there are now roughly 209 tons of human-made debris scattered across the lunar surface, left behind by decades of missions, landers, crashed probes, and abandoned rocket hardware. As more countries and private companies plan lunar missions, including NASA's own plans for a permanent base on the moon, that number is only going to climb. The disposal habits behind that number are already starting to shift unevenly. China's space agency has, in recent years, begun deliberately placing the spent upper stages of its lunar missions into orbits around the sun instead of leaving them drifting near Earth or the moon, specifically to avoid exactly this kind of uncontrolled impact. SpaceX has reportedly aimed for something similar, with at least one more recent mission. But that trick only really works for spacecraft that already have enough energy to escape into solar orbit in the first place, which rules out most ordinary satellites launched into lower orbits. For a lot of leftover hardware, ending up on the moon or drifting back toward Earth eventually just isn't easily avoidable with current disposal practices. There's also a genuinely unresolved legal and ethical question sitting underneath all of this. Nobody currently owns the moon, and no single country or company is directly responsible for cleaning up debris that ends up there. The Outer Space Treaty, signed back in 1967, established that no nation can claim sovereignty over the moon, but it was never designed with modern questions of orbital debris cleanup or liability in mind, and updating that kind of international framework tends to move a great deal slower than the pace of actual rocket launches. As lunar exploration accelerates, experts have started raising concerns not just about future collision risks, but about something a little more unusual: the accidental disturbance or contamination of historically or scientifically significant lunar sites, before anyone has even finished mapping out which sites deserve that kind of protection in the first place. None of this makes what happened on August 5th dangerous, or even particularly rare, in the grand scheme of lunar history. What makes it genuinely worth paying attention to is what it represents. The moment a piece of forgotten human hardware, drifting for 7 months with no one steering it, finally came down exactly where astronomers said it would, read out its chemical signature to a waiting telescope, and left behind one more small, permanent mark in a surface that's slowly, quietly, filling up with them. Beyond what you can see, but never beyond what you can understand. Subscribe and check out the rest of the channel. New episodes on space, physics, and the edges of what we understand, with new content going up every day.